Welcome everybody. In a few moments we will start. Please find your seat if you haven't already and turn off your phones. And most importantly, enjoy the presentation. Welkom iedereen. In enkele ogenblikken gaan we van start. Zoek een plaatsje en vergeet niet uw telefoon uit te zetten. Geniet van de presentatie.
Ik ben Koen, ben 36 jaar en ik ben piloot van March VIII. Ik heb 9,5 jaar geleden een ongeluk gehad. Dat een dwarslesie heeft veroorzaakt bij mij. En toen kwam ik in een rolstoel terecht. 3 jaar geleden ben ik door de Sint Maartenskliniek gevraagd of ik mee wil doen aan Project MARCH. In eerste instantie leek me dat niks. Ze hebben toch gevraagd of ik even wilde gaan kijken. En de eerste keer dat ik ben wezen kijken, toen zag ik Sjaan toen de tijd lopen. En toen dacht ik, ja, dit wil ik ook. En die keer zijn er 3 geworden. De eerste keer dat ik gebalanceerd in het exo stond, dat was een hele bijzondere ervaring. Dat was de eerste keer in 9 jaar dat ik gestaan, of 9,5 jaar dat ik gestaan heb, zonder dat ik me ergens aan vast moest houden. De eerste keer in 9 jaar dat ik echt helemaal vrij stond, gewoon rechtop. Ik kon mijn armen bewegen, gewoon naast dat ik rechtop was. Dat was echt een hele bijzondere ervaring. En het stomme was, ik had ook gewoon gelijk het idee dat ik zou weg kunnen lopen, zeg maar. Net of er een schakelaartje omging, oh, ik sta weer, dus ik kan lopen. Dat was echt heel bijzonder, ja. Nee, ik denk niet dat het gaat werken. Ik weet zeker dat dit gaat werken.
I am what is left when all is said and done. You have all of me, or you have none. Lose me, and you will surely fall. For I am what helps you stand against it all. So, I see quite some confused faces about what I just said. Don't you worry, I won't keep you in suspense any longer. The answer to this riddle is balance. Welcome, everyone. Welcome to the reveal of the Project MARCH VIII Exoskeleton. My name is Marilène Dorkland. I'm the team manager of MARCH VIII. And balance is what I would like to talk about today. See, it is something that has dominated our world since the moment it was created. Our world was a big sphere of melted rocks with radioactive elements all around. After a few million years, the balance in temperature was found to form a crust, and on top of that, the ocean. This happened about 3.8 billion years ago, which is quite some time till now. So to make sure you won't have to be here till midnight, I'll skip some parts and go through this a bit faster. After another few million years, the balance in temperature and oxygen was found to create life. A final big crash of a meteorite resulted in the optimal living conditions for our ancestors to develop themselves. Our ancestors were unique in quite a few things. They made use of tools, knew how to control fire, and found a way to balance on 2 feet instead of 4. See, the whole point I'm trying to make here is that everything in this world is about finding the perfect balance. We see the ability to walk on 2 feet as something completely normal. It would just be highly impractical to not be able to use our hands during walking, right? How could we otherwise check our phones, grab a glass of water, or check our hair to make sure we look good? But you see, it's actually quite special that we can do this. Just to mention some things, our spinal cord had to evolve in such a way that we could stand up straight. Next to this, the position of the skull and the neck, the stability of the pelvis, and the relation between our thigh and our knee all had to be in balance for us to balance ourselves. Let's focus a bit on how the legs themselves evolved to make us stand up straight. One leg is built up from 1 upper leg bone, 2 lower leg bones, and 30 muscles. Connected by a complex nervous system, they communicate with the brain. It is of paramount importance that the muscles and bones are strong enough to carry the rest of the body, and that the nervous system is able to communicate flawlessly. So, what happens exactly when you have a spinal cord injury, also known as paraplegia? Paraplegia entails that the nervous system is damaged at a certain height of the spinal cord, causing to have no motor or sensory function below the height of injury at all. It often results in being wheelchair-bound. Being wheelchair-bound has a huge impact on the human body. The muscles and bones we just talked about are weakened. Your blood flow goes down, and so does your cardiovascular health. Besides the physical disadvantages, it goes without saying that being wheelchair-bound has a negative impact on the mental well-being. The members of Project MARCH have the vision to improve the lives of people with paraplegia by pushing exoskeleton technology. An exoskeleton could be explained as motorized robotic legs attached to the outside of the body, enabling the user to stand up and walk again. To make sure we make those robotic legs as human-like as possible, we take a very close look at the anatomy of the legs. First, the skin. It's remade by the covers surrounding the exoskeleton to keep it safe. Then the bones, which are recreated by the frame, and the human joints, which are mimicked by motorized power joints in our exoskeleton. The combination of those two make it possible to flex and extend the hips, knees, and ankles. Shortly, they make it mechanically possible to walk. Next to this, we have to recreate, of course, the nervous system. And we do this by having a very big network of electronics. They make sure the right signals are transferred through the motors so the exoskeleton knows when to move. Finally, to make sure we set suitable steps with fitting speed, our exoskeleton is controlled by our own written software. It functions as the brain and is carried around with a small computer in our backpack. You can imagine that building such a complex suit takes an incredible amount of work. Luckily, we are a team consisting out of 27 highly motivated students and 1 daredevil of a pilot, Koen. We have 11 different study backgrounds and are divided over 9 different departments. On the 8th of August 2022, we came together for the very first time to form the 8th team of Project MARCH. 27 personalities, 27 opinions, and 27 brains full of ideas. It will not come as a surprise, but also here we had to find a form of balance. A form where we could work together and empower each other. We had to create an environment where it was okay to fail and have the room to grow. We had to create our own small evolution. And this we did. We evolved as individuals, as a team, but also as a project. And to evolve in such a way, you have to set high standards, high ambitions, high goals. I could go on about this, but I know someone who is more suitable for this. Tess, come and help me out, please.
Marilene is completely right. The evolution of Project March is an inspirational one. Project March started 8 years ago, and in those 8 years, we achieved a lot. We were able to have paraplegics stand up from their wheelchair, set their first steps, and even allowed them to walk outside again for the first time in years. Previous Project March teams pushed the boundaries of exoskeleton technology. We granted paraplegics the opportunity to walk alongside family and friends at the same height. But to understand the complexity of these achievements, I want to tell you more about walking. My name is Tessel Huybrechtse, and I am this year's motion planning engineer. Walking on 2 legs is something most people take for granted, but which is a skill that is actually quite specific to humans. Currently on Earth, only one other animal of our size has developed this skill in the same way as us, the ostrich. However, many years ago, when dinosaurs were the most prevalent species on Earth, most of them walked on 2 legs as well. It clearly has to have an advantage. But what is it? Well, first of all, walking on 2 legs allows for better vision, as your head is upright and higher. But most importantly, walking on 2 legs allows you to use your arms for other things. For dinosaurs, walking on 2 legs meant they could use their arms as weapons to catch their prey. For humans, catching a cow with just our arms wasn't really an option. So instead, we used our free hands to create tools to do it for us. Using these tools, we could also build homes and villages, which eventually led us to where we are now. But how exactly does walking work? A mature walk requires a tremendous amount of coordination between all parts of your body. The precise synchronization between the movement of your hips, knees, and ankles is essential in creating a smooth movement during a step. However, walking doesn't only consist of this direct communication loop between the muscles and the brain. To be able to walk, you also need to know where your body is in space. And to illustrate this, I would like to do a small experiment with you. So if everyone can close their eyes, put a finger up in the air, and then try to touch your nose. As you can see, this should go quite easily. But if you think about it, it's actually quite fascinating, as you can't see or touch anything to determine how far away your finger is from your nose, and yet you are able to bring them together in a straight line. This sophisticated capability, together with input from your eyes about the space around you, allows us to take smooth steps at all times. During such a step, one foot is swinging through the air, and one foot is standing on the ground. In this position, stability is a crucial challenge. Such a challenge that in previous years, we weren't able to achieve this with only the exoskeleton. Instead, we worked with crutches. This meant that at all times during a walk, Koen would lean on his crutches for stability. However, this also meant that walking became a physically exhausting task, and that Koen could not hold anything in his hands while he was walking. Think about how often you use your hands while you are standing. Do you already see the possibilities that an exoskeleton without crutches could give? Just like evolution caused humans to walk on 2 feet so they could use their arms freely, we want to do the same for paraplegics. We want to give them back the abilities that nature gave us when we started walking on 2 feet. It is the dream that has been in the back of every Project March team's mind. The dream that seemed impossible, but also the dream that we, March VIII, set the first steps towards. A balanced exoskeleton without crutches. And let me tell you, it was no easy task. Balance is an extremely complex process of the human body that you can't just mimic easily. Our bodies use over 200 muscles to make sure we stay upright at all times. Every muscle sends signals at exceptionally high speeds to our brains. Our brains have to interpret and process those signals to make new decisions each split second about what to do next to keep our balance. Our human joints allow for over 240 different directions of movement. every direction can contribute to maintaining balance. You can imagine that squeezing your toes to hold onto the ground is enough if there's a little push from the wind. But if someone bumps into you and you only squeeze your toes, you will fall over. But how does the brain make these decisions? Well, on the one hand, it responds through reflexes. It senses a force and it reacts with an opposite force instantly. On the other hand, the brain also learns through previous experiences. The first few times you tripped over a tree trunk as a kid, you fell to the ground. But as you grow older, you learn how to catch yourself. The combination and collaboration between all these processes is what allows us to stay balanced all throughout our lives. All of these things were everything but easy to achieve in an exoskeleton. It took nature over 2 million years to achieve it in humans. We decided to do it in 1 year.
Building a self-balancing exoskeleton in a year. What does that look like? We started the year in this room, thinking of what we wanted to achieve the following year. We studied all work performed by the last 7 years of March to learn from the achievements and mistakes of past years. On top of that, we got in touch with our partners to develop a deeper understanding of what it takes to build an exoskeleton. In the following phase, we started studying and gathering data. By processing this data and combining it with research of previous years, we can simulate different ways to make the exoskeleton move. Around the same time, work starts on the design of the exoskeleton. What shapes, what colors? And before we can make the final product, prototypes are printed, tested and iterated. Parallel to this, the frame and joints of the exoskeleton are calculated and designed. All this happens in close collaboration with the other departments to make sure all parts work together seamlessly. After the design has been finalized, we start with production. The majority of the parts in the exoskeleton we manufacture ourselves in the dream hall. Once all the different parts have been manufactured, we can start assembling them to test if everything works as it should or if changes have to be made. The different types of chips, sensors and cables make sure all the power and data are transmitted as it's supposed to be. When all is finished, the exoskeleton is ready to be assembled completely. After the assembly, it is extensively tested and debugged to make sure all components work as we want them to. Once everything is done, it brings us to where we are now, the reveal of the Project MARCH VIII Exoskeleton.
The perfect exoskeleton is like your own shadow. When you move, it moves with you. When you fall, it falls with you. And when you walk, it is always by your side.
Building such an exoskeleton has been a vision of Project MARCH for many years now. And with the March 8th, we have come closer. Because a self-balancing exoskeleton needs a shadow that faithfully mirrors your movements, capturing even the subtle adjustments you may not consciously be aware of. It's like your own body keeps itself in balance automatically, and these nuanced movements reveal themselves in the dance of your shadow.
Developing an exoskeleton in one year means a process of overcoming obstacles, facing challenges and reacting quickly. That resulted in our exoskeleton, the March 8th, an evolution of human and machine.
My name is Joy Brandt, and I'm this year's Chief Software Engineer.
And I'm Wendel Posma, and I'm the Chief Engineer of March 8th.
The human body, truly a masterpiece of engineering. It's a marvel of complexity, adaptability, and efficiency, enabling us to perform a wide range of tasks, from the day-to-day to the extraordinary. The March 8 aims to mimic these complex movements. With joints in the hips, knees, and ankle, we can allow the pilot to naturally move in all these different directions. However, allowing the pilot to do this in a balanced way adds another layer of complexity. Today, we will dive deeper into this process together.
So let's start with one of our biggest contributors to balance. They're now twice as fast and stronger. I'm talking about our linear joints. You can find these in the hips and in the ankles. With enough force in them to carry 3 times the weight of Koen, we rely on their strength to keep Koen upright. These joints allow us to move our hips from side to side and our feet up and down. And with the improvement of these 4 joints, we have unlocked 8 degrees of freedom in total. This means we can compensate for imbalance in almost any direction and allow for more natural movement in the lower body. But how exactly are we sure our movement is as natural as we want it to be?
Good one. We use our sensors for that. In all 8 joints, a sensor is placed to measure its angle. For example, if our exoskeleton is standing upright, a 180-degree angle is measured in the knee joint. In addition to that, we've placed a sensor around the hips to accurately sense the state of the exoskeleton. Together, it measures the orientation of the whole system in comparison to the ground, answering questions like whether the body is upright, leaning forward, or tilting to the side. Our exoskeleton responds to each situation with compensating movements, ensuring it remains stable while preventing falls. Obviously, Koen already has his own organ of balance. Now we can say he has 2 that keep him in balance.
And while we now know the orientation of Koen, the exoskeleton itself lacks the knowledge of the ground beneath. Luckily, our exoskeleton has feet similar to our own, with its nerves. To mimic the nerves, the foot plates have something called a pressure sole. These soles measure the force executed by the pilot in the exoskeleton to the ground, answering questions like which feet is on the ground, and we can also see where the pressure is high and where it isn't. With this knowledge, we can check if our foot is firmly planted on the ground so that we are sure we can start moving our other foot.
If everything is going well, the foot will be placed firmly on the ground. But what if it doesn't? We've all experienced moments from our childhood when we run like hell on our flip-flops until you suddenly scrape your toe on the ground. Such incidents remind us that our feet can reach the ground sooner than expected, in a position that wasn't ready for impact. In the past, March used a control method that couldn't foresee such incidents. The impact with the ground was rigid and unstable, which made it hard for Koen to keep his balance. This year, we eliminated this concern by adding torque sensors to all 8 joints. With this huge accomplishment, we are able to precisely control our exoskeleton, preventing any untoward incidents to maintain stability.
In combination with our other sensors, our exoskeleton aims to mimic the sensory functions of the human body. Of course, our amount of sensors is nothing compared to the billions of neurons in the human body, but still, we are able to mimic the essential characteristics necessary for maintaining balance. And just as the human body sends its messages through the nervous system, our exoskeleton operates in a similar manner. The information collected by our sensors is sent via the joints to the brain of the exoskeleton, allowing the brain to make appropriate adjustments based on the situation. But what happens in the brain to ensure our movements contribute to our balance?
That's quite a complex question, but I'll try my best to explain it. Let's say I want to get to the chair over there. As I'm speaking, my brain already sketches a path for me to get there. I make deliberate choices about my step length, step height, and even my walking speed. I have to make sure my center of mass is in between my feet to guarantee I'm in balance. While I'm walking, I smoothly shift my weight from my right to my left. Every millisecond, I subconsciously make small adjustments to walk upright, ensuring I don't fall over. I take it for granted that these deliberations result in my balance, but the reality of it is that I only have 2 feet to stand on.
That's right. Through evolution, we've come to accept this rather complex process as a given. But recreating it in our exoskeleton, that was a huge challenge. And doing it while staying in balance, even more so.
That was it for sure. Right now, our system collects all our sensor data, from the motor positions to Koen's own posture. The brain then processes this data and generates a walking pattern. It can think of 100 ways to walk every dozen milliseconds and then chooses the one that is in balance. That's what our human brain, and now also our exoskeleton's brain, can do. In our exoskeleton, we call this the model predictive controller, or in short, MPC. It constantly predicts hundreds of future paths and compensates the exoskeleton accordingly. It's like our own mathematical fortune teller, telling the exoskeleton what movement will result in it staying balanced.
Isn't it amazing? Hearing this, I think the exoskeleton is probably smarter than I am. You can just jump into it and it will sketch hundreds of paths for you to follow. There's only one question left. How can Koen control the exoskeleton exactly?
I didn't even think of that.
That is exactly how Koen can control the exoskeleton. By only thinking of it. I am talking about our EEG headset. This device can measure Koen's brainwaves and use it as inputs for the exoskeleton. In the past, March has already made it possible to start walking without pressing a single button. But since seeing Koen walk on right into walls without stopping was not so user-friendly, we had to improve it. With our own customized software, the March VIII EEG has the improved functionality to also stop walking. Not a single button has to be pressed. The exoskeleton will simply read Koen's brainwaves for it.
Now then, this all sounds so exciting. Let's show everyone the potential of our self-balancing exoskeleton.
Feels like the first time I made time in a minute. Rock with it, I'm in attendance. How can we pair feelings aside? I gotta match the fires to the flame. The feeling just got attached. I got the days fall, the straight fall away small. The waist started dancing on me. Had to take you back home. Time moving slowly, fast forward.
I still get goosebumps every time I see our exoskeleton march on like that.
And don't forget, this is the first time Koen walks hands-free after all his experience in March exoskeletons.
We've just shown you how our exoskeleton is smart and can think of 100 ways to walk every dozen milliseconds. But in those walking patterns, Koen's idea on where to walk and how to walk is not taken into account yet. Brain control is still in its infancy, but it could change this forever. By keeping the development of EEG going for multiple March years, we foresee a future in which Koen and other paraplegics can use their thoughts to control their legs. Together with our balancing exoskeleton, this is our vision for the future. A future in which a self-balancing exoskeleton can not only start or stop walking, but walk faster, slow down, or to turn around and watch a pretty sunset. Not because you clicked a button, but because your thoughts guided you there.
That is what Project March is about, using technology to create a better future for paraplegics worldwide. We know technology can be used for good, especially for those who need it most. There's a lot of potential everywhere, and our EEG headset and suit are just examples of that. To discuss our vision of the future of technology in healthcare, I would like to make room to invite intensive care specialist Diederik Gommers to the stage.
Dieter Gommers, thank you for being here.
It's very nice to see you here, and I'm really impressed. Unbelievable what you did together.
Thank you so much for saying that. Like Joy just mentioned, we'd love to talk to you about the future of technology and healthcare. Of course, we are all engineers, but we'd love to see your opinion as seeing healthcare up close. So I'd like to start with my first question right away. You've seen the intensive care and the hospital from up close. What technologies do you think have changed the hospital over the last 20 years the most?
Yeah, the most is very difficult because we need all these innovations. That for the diabetic now, that you can measure your glucose all the time, and that you can really, with your mobile phone, you can add more insulin. That is an impressive innovation. And of course, we also have them in the hospital. On the ICU, we have now heart-lung devices. They are normally used in the OR. They are huge machines. Now they are so small that we can put them near the bed, and even the doctor now, when he's going to the helicopter by the out-of-hospital cardiac arrest, he takes all the equipment with him. It's really small, and then they can put in the catheters, and they can take over the lung function and also the heart function. Yeah, that is really impressive, that we can really try to keep someone alive with these innovations. And what you can see also, what you have showed, how long it takes. You are now 8 years working on this. It's really impressive what you did, but of course it takes a long time. But what we see now with the software and all the new young people, hopefully it will be a little bit faster.
Yeah. And what you said about the sensors getting smaller and people who can even measure stuff with their smartphones, do you think there's a trend of people taking healthcare back home rather than doing it in the hospital?
Yeah, what we are now looking for, we have a shortage on nurses, and we see that there are more elderly people. We become elder. And that means that we need more to give more care, but we don't have enough people in the hospitals, and also the general practitioners is limited. So that means that a part of the care should be given at home. And we have experienced during the COVID that some of the people can stay home, and that they were giving additional oxygen, and that we can measure vital signs, and that we can show on screens what the values were, and that we can add some change the therapy, or we ask them to come to the hospitals. I believe that will increase in the next years enormously, but then of course we need this additional innovations.
That's very true. It's also great to see so many other examples. Of course, I thought of some, but you bring up even more examples of technologies that have changed healthcare. Everybody in Project March has mostly an engineering background, but what we do with Project March is, of course, helping people who need it most. But we're not doctors. So how do you think us technical students could help hospitals in the future, even with this shortage of people that you've just mentioned?
Now, what we learned from the COVID is that in the beginning we said, okay, we as doctors, we as hospitals, we can solve everything. But when you look back, maybe we did it wrong. Maybe we should have opened up the doors, describe our problems, and ask people if they can help us. And that's what I learned from the COVID period. And that's also what you see now with the Erasmus Medical Center in the Convergence, together with the TU Delft and the that we need to work together. And what we see now in my department, how important is to bring in, or to invite young people from the TU Delft, and then show them what we are doing in daily practice, and they have an open mind, what you also do in your program. You start every year with a new group to have new ideas. And that is for me so important, that we open up the doors from our ICU, from our hospital, invite young people with from other disciplines, and ask them, okay, describe, this is our problem, do you have ideas how to solve that? And then the same with your face, you're laughing and a good of energy, and that is of course also important to bring in the hospital. So I'm glad that we have this cooperation with the TU Delft now.
Yeah. It's really great that you mentioned this. That's why I'm smiling. It's of course why I think every one of us has started doing Project March. I mean, what we've done for Koen this year and what previous Project March members have done, it's all because we want to show that smile that I have right now also on patients' faces. So it's really great that you mentioned this, and I think you also do a big part in that. And I know you teach at Clinical Technology, which is TU Delft and Erasmus, so that's a great start, I think. And maybe in the future, we engineers can just walk into the hospital and see, well, I have a new solution, and let's try to make it work. I've got one more sharp question, maybe. What I've heard and what I've seen is that technology can also be scary. I mean, technology can be loud, or it can be moving fast. How have you seen patients' reactions to technology, and how do you think we can improve that?
Yeah, what we have to look out is that what we also have seen in the COVID in the first time, that we were not allowed, that family came in the ICU, and that people were alone and someone died alone. And that's not very empathic. And this empathic is so important, the human-human interaction. And therefore, we have to look out that we bring in too much innovation and that we don't have the real contact between a nurse and a patient or the doctor and a patient. And that is most important time. But what I believe is that these innovations could help us, that we have more free time and really can have time to have real contact with your patients. What I'm saying now is every nurse, every doctor should have time to drink a cup of tea each day with their patients. And then we are successful.
I think that's great to hear, and I hope that in the future we can make this happen with technology. I know that a future balancing exoskeleton or a future exoskeleton in general might be able to give someone the care back home, and then when they really need it most, they can sit down for a long time, enjoy a coffee or enjoy tea with their doctor. I think that's a good vision for the future.
Yes.
Okay, I just got a sign on stage that we're ready for the live demo. So I hope you're as excited as I am for this.
Yeah, absolutely, absolutely.
Okay. So then we're going to wrap up this interview. So, Dirk Gommers, thank you very much. Today, we are very proud to show you our self-balancing exoskeleton and the potential it has for the future to develop it even further. Just like evolution, we chose different paths, and in the end, we know we chose the right one. But just like normal evolution, in order to evolve in the best way possible, it is of great importance that some things happen with a great deal of attention. This path that we're on takes time, and unfortunately, time was our biggest enemy this year. The full potential of a self-balancing exoskeleton lies on this path, and today we are extremely proud to show you its first steps. I'd like to ask you to be completely silent as the demo takes place, so Koen and the rest of the team can focus. Please enjoy. As you might have seen already, we are experiencing some technical difficulties. We developed an exoskeleton in 1 year, and we try to make it balanced in 1 year. And unfortunately, in that time, we have very, very little time for troubleshooting, so our exoskeleton doesn't work 100% of the time. This looks like a problem we might be able to fix. What we currently see is that sometimes with all these new sensors, we ask a lot of the system, and then data doesn't really come through often. What you can also see then is that the exoskeleton stops in a safe manner. And we can simply let Koen sit, and then we can restart the exoskeleton. That's what we're currently doing. And we need a little bit more time for that. So that's what you're seeing here. This is maybe even a uniquer insight into the life of a dream team. You try to do something in 1 year, you know it's close to impossible, but you can make it happen when you shoot the video, you can make it happen when you have the rehearsal, but it doesn't work when you're standing right here. That's how it goes. We'll just take a little bit more time, so please be patient, and we'll be with you shortly. All right. It looks like we found the issue and 10 other more, but we are going to try again. And of course, like I just said, please be completely silent as the demo takes place, because it's also very important for everybody to focus here. And we'll give it one more go. Okay, we're starting to come to the final solution. Sometimes it helps to put the exo in a different angle, sort of move it around, which you'll probably see happen now. And what do you say? Yeah, if everybody could just make a prayer for the exoskeleton, that would be nice. Let's wait just a few more minutes and then we'll continue the presentation. Unfortunately, we didn't manage to get it working, but we have a closing end to the presentation that we'd love to give to you and see it as a fitting year for this exoskeleton. So I'd like to ask Mari to come to the stage.
Well, you have experienced together with us the definition what it is like to be a dream team. It's a lot of bumps on the road. We have grown as a team to be, very well played into each other, and sometimes that doesn't work. We will get Koen out of the exoskeleton right now, and then we will have a small Q&A with him, because he has walked in his exoskeleton, and you, of course, saw the video. You see the potential of this exoskeleton. So we will talk with him about how he felt walking in this exoskeleton and, how he sees the future of this. But for right now, like you see, Koen is getting out of the exoskeleton, so it's my job to entertain you a little bit to them. And it gives me that perfect opportunity to thank Havenbedrijf Rotterdam RDM and our partners Hogeschool en Techniek College Rotterdam for supporting us and making it possible that we could present here. This truly is a place for innovation, which can also be seen from all the tech startups based here, and it has been an honor to present our exoskeleton here. Thank you. All right, we will have a small moment. Koen is now hopping actually out of the exoskeleton. He is very well trained in this by now. There he is. Here you go. Koen,
Hello.
how are you feeling after this overwhelming experience?
What should I say? A little bit disappointment, but yeah, it could happen, of course. It's still some mechanical things. It's really the first time it happened this way. Yeah, too bad.
But of course, we did see you walk in the video.
Of course.
And we have some very pretty shots of what we actually have accomplished this year. For example, we saw you walking hand in hand with Sis. Can you tell us a little bit more about that experience?
It was a really great experience. I never thought we could make it, in the beginning at least. It was really very nice to do. It was a super experience we did last week. The guy who made the film was also wonderful, with great shots, with great weather. Everybody was super enthusiastic, and yeah, we just nailed it last week. It was super, really.
And how did you experience actually the first time in, well, 9.5 years that you could just stand up straight and use your hands again? How did that feel?
There was a moment where I almost had some tears. It was unbelievable. For the first time in 9.5 years, I could stand and use my hands and look somebody in the eyes without using crutches or something. It was a great experience. Yeah.
Nice. And well, this is the definition, of course, of it, but up until the very last moments, this year was an absolute roller coaster.
It's still.
It's still. How did you experience being a part of this team?
Being a part of this team was great. Last 2 years were also super, but how do I say it? Give it some extra. It was the goal was set very high, and we almost achieved everything. So it was super and great. It was a really great year. Thank you very much for everything.
Koen, it truly was an honor to have you as our pilot and member of our team. Thanks to you, your positivity, extremely high perseverance and willingness to always push harder, we have come so far. This has not only been for the last 3 years, but for the last year, but for the last 3 years that you have been a part of Project March. So thank you for everything you have done from the whole March community.
Thank you very much.
Ik mag blijven voor de foto. All right. I do understand that some of you also have some questions for Koen, so please come and look for him during the drinks. He's happy to answer all of them. Preferably in Dutch, right, Koen?
It could be, yes.
Nice. As we are coming to an end of this presentation, we are also coming to an end of what has been an incredible adventure for the team members of March VIII. But we weren't alone in this adventure. We've had the most amazing support of our partners guiding us through problems if we didn't find the answer. Thanks to your support in funding, parts, and consultancy, you have really made it possible to push this project to a new level. You are the community we can build on. I'm excited to see what upcoming Marchiers are going to learn from you. This being said, leads me to a final task to do. Introducing you to the team. Project March VIII is a team filled with extraordinary people. Smart, high in perseverance, but most importantly, kind. After 50 weeks, this group feels like a family, and it will be weird not spending our days together. Friends, it has been the greatest experience, the greatest adventure, the greatest honor to work with such an incredible team. Please join me on stage. The mechanical department, Storm, Chris, Lieselot, Bas, Sanne, and Lika. The human department, Lisa and Tijn. The software department, Tessel, Joy, Jack, Sophie, Marco, Sahant, and Rix. The electrical and embedded department, Joost, Tias, Lena, and Casper. The operations department, Marije, Sanne, Tim, and Jaron. And the management team, Gunnar, Wendel, and Leo. our Project March VIII. Thank you all for coming. Nice, guys. Guys, I'm proud. Group up. Come. Woo! Die komen hier. Jongens. Ik ben heel erg trots. We hebben het fucking goed gedaan. Het is jammer dat het op het laatste moment niet goed werkt. Sorry. I'm really proud. We worked very hard. I'm really proud of what we have done. It's a shame that it doesn't work right now, but we know what we have to accomplish. And it's just for a few seconds, and we did very well. I'm really fucking proud. Okay? Woo! What's that?
Drinkjes kunnen...
Yeah. There are drinks in the same room as we had the interactive fair, so please enjoy.
Fucking goed gepresenteerd.
Ja?
Tering goed, het ging echt fantastisch.